This video covers Stat 454, Chapter 3, Section 1, Introduction to Linear Programs. We'll begin by looking at homework number 1 in this section. Farmer Jones must determine how many acres of corn and wheat to plant this year. An acre of wheat yields 25 bushels of wheat and requires 10 hours of labor per week. An acre of corn yields 10 bushels of corn and requires 4 hours of labor per week. All wheat can be sold at $4 a bushel, and all corn can be sold at $3 a bushel. 7 acres of land and 40 hours per week of labor are available. Government regulations require that at least 30 bushels of corn be produced during the current year. Let x1 equal the number of acres of corn planted and x2 equal the number of acres of wheat planted. Using these decision variables, formulate an LP whose solution will tell Farmer Jones how to maximize the total revenue of wheat and corn. As we read through the problem, we should be able to pick out important pieces of information. First, these things called the decision variables. Each one has a particular meaning. X1, the number of acres of corn, and X2, the number of acres of wheat. With these two pieces of information, we know that we have a goal. Our goal is to maximize a quantity that I am going to call Z, and that Z should depend on the decision variables X1 and X2. Let's take a look at how we would calculate Z, knowing that $3 per bushel of corn is how much we're going to be paid, but we have 10 bushels of corn per acre yields $30 per acre of corn. This is important because the units of $30 per acre will cancel with the units of units of number of acres to give us 30 times x1. Dollars per acre times number of acres gives us a number of dollars. Performing a similar calculation on the acres of wheat, we find $100 per acre of wheat. This expression right here is called the objective function. Taking into consideration the other restrictions upon the results of this problem, we come up with three expressions in a similar manner. 4x1 plus 10x2 less than or equal to 40. This is the labor restriction. x1 plus x2 less than or equal to 7. This is an acreage restriction. x1 bigger than or equal to 3. This is the government restriction that they placed on the amount of corn that was being produced. And here's a restriction that students tend to forget since these quantities have practical meaning. The acreage must be a non-negative number. It doesn't make any sense to have a negative acreage. Combining all of this information together, we have an expression that looks like maximize Z equals 30x1 plus 100x2 subject to these following conditions: 4x1 plus 10x2 less than or equal to 40, x1 plus x2 less than or equal to 7, x1 greater than or equal to 3, and x1 and x2 greater than or equal to 0. This entire expression is called a linear program. This expression is called the objective function. These coefficients are called the objective coefficients. These three equations are called the constraints. And x1 and x2 being positive, non-negative, is called a sign restriction. This expression is called an LP because it is a combination of linear inequalities. The objective function is a linear function. The constraints are linear functions. As we move forward in the course, our goal will be to determine solutions to this LP, values of x1 and x2 that maximize z. But for now, it's worth asking, are there any values at all that satisfy this LP? In other words, are there any feasible points? All a feasible point is a ordered pair x1, x2 that would satisfy the constraints. Can I plug any point into all of the constraints and have them all be satisfied? If you look at homework problem number 2, we have a collection of points to test. The first one, x1 equals 2 and x2 equals 3. Is this a feasible point? In order to determine if it is or not, I'm going to plug it into these constraints. Excuse me. And it helps if I write it down correctly, like that. No, that was correct. There we go. All right, so let's take a look at these points and start plugging them into equations and see if they're all satisfied. Now, you could go through every single equation every single time, but I recommend seeing if there are any that naturally stand out as not being possible. And for this one, I notice x1 bigger than or equal to 3. This point is not feasible since 2 is less than 3. Here's another point. Is this point feasible? Does it satisfy the constraints? I'm going to plug this into the first constraint equation. This quantity is 16 plus 30, which is 46, but the constraint says it should be less than or equal to 40, and it's not. So this point is not feasible. Let's try this one. Four times 3, 10 times 2, 12 plus 20 is 32. That quantity is less than or equal to 40. That checks out. 3 plus 2 equals 5, which is less than or equal to 7. That checks out. And 3 is bigger than or equal to 3. That also checks out. Since all points satisfy the, all constraints are satisfied, we get a feasible point. And I should mention also, notice that these 2 points satisfy the sign restrictions as part of feasibility. There are a collection of keywords associated to to the kinds of numbers that go into an LP. Probably most importantly, the divisibility assumption. In an LP, we say that the LP's divisibility assumption is satisfied if fractional values of x can be found. Notice that in real life, this might not necessarily make sense. There might be times where you want x to actually attain a whole number of values. There's a field of study for that, but it's not technically an LP. There's also the certainty assumption. It's when all of the coefficients are known exactly. And again, you can imagine that in real life, there are times where you don't know all of those coefficients exactly. That's another field of study, but it creates a thing that is not an LP. So as you work on Chapter 3 material, a thing you should try to do is make sure that the units of every coefficient that enters into the LP is clear and consistent with the decision variables and the objective function. Right? It's going to be coefficients units times decision variables units, yielding objective coefficients. And you're going to repeat a similar process for the constraints. The homework associated to Chapter 3.1 is homework number 4. That ends discussion for Chapter 3, Section 1.